All right, so I'll introduce myself and my co-authors. We are the team from Oracle, and I'm working for Oracle Labs. Recep Bekci is my intern who is doing his PhD at McGill University in Montreal, Canada. Jorge is a data scientist at Hospitality GBU Global Business Unit at Oracle. And Kirby is Jorge's boss and the former CTO of Norwan. So I'll just introduce, if I click here, will it work? Okay, let's try this. Okay, so I need to click here. So I'll introduce the problem, and then Recep will take over. So Recep, you may move to the carpet for the kind of to be ready. The idea is that multiple customers booking at multiple hotel properties, that we have multiple customers booking hotel properties. And those hotel properties are similar. So we want to aggregate to pull those observations together, but we also need to be conscious of two things. Some differences among the properties, and the second, that not all properties want to share their data. For example, you have like Hilton properties and Marriott properties across the street. Hypothetically, they don't want to share their data either for like because of the ownership, or it is logistically difficult because they're in different areas of the cloud services, or maybe on different service or something else. So we're coming with two solutions. When we have when we want to aggregate the data and we're allowed to share the data, we use this model called hierarchical modeling using Bayesian approach. And when we want to combine the data from different properties, we actually use federated learning that allows for sharing the models rather than sharing the data. And this is kind of a very common machine learning approach these days, mostly used for privacy, for privacy preservation. Privacy. So this is a general kind of like chain. I mean the flow diagram. The offline model training happens in the green square on top. Then this kind of predictor module interface is used by the optimization module, and the optimization module does all the optimization, for example, price optimization. So model training, we thought of this two kind of like two-level approach. So at one level, we feed the hierarchical model, collecting the properties from the same chain, from the same owner. And then we actually, on top of that hierarchical model, we combine them using the federated learning. And I think the next Recep will take over and explain how federated, how hierarchical modeling will, I will walk on step aside.
Hello, everyone. So my name is Recep, and I will describe the hierarchical model that we use. Hierarchical model is used for data that has multiple levels. In our case, we have different properties in the same hotel chain. So this can be modeled in two extreme ways. The first one, we can pull all the data and do train a single model. And in the other extreme, we can feed a single model for each property. So we will have models with the number of properties independently. And what the hierarchical model offers is combining these two extremes. And in the first extreme, you can have a bias problem because you are aggregating all the data and you don't take the individual concerns into account. And in the other individual models, you can have variance problem because you are using little data for each property. And in the hierarchical model, it offers to combine the benefits of these two extremes and reduce the harms of these two centralized and decentralized training. So in the next slide, I will talk about how we aggregate these individual models. We will use a common distribution, which is normal. And it has two parameters. And in order to have the perks of Bayesian inference, we also assign priors to these two distribution parameters. You can change slide. Yeah, here I will describe our model. So we have three stages. In the first stage, we have the observed data. This data is responses of customers for upgrade offers. So it is a binary data. And in the second stage, we have a logistic regression model, and all the parameters are tied with a normal distribution. And in the last stage, which is the third stage, we have a prior model. And in the next slide, I will detail these priors. We have priors for variances, both promotes the low values. For the prior of sigma, we are using gamma distribution. And for the prior of the variance of mu, we are using Cauchy distribution. They both promote lower values, but gamma promotes a little bit away from zero. So this will benefit for some kind of exploration in the beginning of training. So these are both informative priors. So we can skip this. And this is the model that we used. So to summarize the model, it offers a balance between centralized and decentralized learning. And it gives the opportunity of embedding prior information and having posterior distribution over the parameters would be beneficial for uncertainty quantification, and we can have credible intervals for our predictions. So that's it for my part.
So describe the federated learning level of our approach. Jorge, I think you need to move to the carpet. Okay, let's see. Jorge, are you there? So let's wait a second. I can see. Okay. All right. So let's give Jorge a minute. And meanwhile, if you have questions about the hierarchical modeling, you can ask us. So this hierarchical model, I can kind of like talk a little bit more to fill the pause. So the the idea actually is like to use this Bayesian approach, and we use this software called STAN. So it uses the Hamiltonian Markov chain, Hamiltonian Monte Carlo, that kind of speeds. I think the idea is pretty much the same as MCMC, Markov chain Monte Carlo, but it by using Hamiltonian, it speeds up the calculations, and things actually go much faster. So we can run computations with many more observations and many more parameters. It's still work in progress, but okay. So like let's see if Jorge can fix. So I can actually start, and then Jorge will take over. So the idea of the of the federated learning is to instead of combining data, to combine the models. And in the models, you can think of the there are different ways to do it. And what we did is the horizontal federated learning. When we combine the coefficients, if it's like a parametric model, we estimate some coefficient parameters, and then we combine them at the server. So we have clients at the kind of federation client level that do the hotel property client model, and then they bring them at the hotel chains centralized model. So at that point, from every, like the data sharing kind of stops at the chain level, and then the data from the chains are combined. Sorry, not the data, the models from the chains are combined by averaging the parameters. There are different ways to do it. Like another way is to do gradient search and averaging the gradients of the parameters, but we did this a little bit like simpler approach just to see how it works and put together the general framework. So the kind of picture there, another way to look at it is that we have like multiple stage, and we get the initial model parameters, then we do the federated training, where we kind of communicate this kind of to the top of the pyramid, where at the top you have the federated, actually it's like supposed to call the server, on the right, and over there you combine the models, and then you do evaluation, and you may actually run several iterations of that. So the results are kind of interesting, they look interesting. So we tried to compare, it was actually the data where the also the upsell efforts from the hotel and the acceptance of the customers that we wanted to estimate based on the different like parameters of the model. Since the acceptance rate is very low, it's about maybe 5%, we kind of thought the best way to do it instead of like accuracy or kind of the score, we used the area under the curve, which is more kind of like more reasonable measure of accuracy, or like of the model performance. So
what kind of model did you train?
we used logistic regression model. So for every customer and for every offer, we try to independently estimate the probability of the acceptance of the offer.
And this is across multiple hotels that
Yes, yes, it's
in a given locality.
yes, it's multiple hotels that are similar. I mean, we kind of didn't know which hotels they are, but we knew that Nor1 was like doing pretty much the same hotel grouping. So we followed like Nor1 kind of strategy of grouping different hotels together.
So for the models, I assume the model would have to be similar across hotels, right? So
Yes.
You have to have same product categories.
Yes, we have similar. Well, we had similar. There were slightly different parameters. There were more like customer characteristics, like booking window, price offered, and kind of like day of the week of the arrival. So it wasn't exactly. We didn't use the utility function. It's more like kind of parameters of the user, of the guest, combined with the parameters of the booking. I mean, like booking parameters combined with room. Yes. So they're kind of like the columns were common. Like we didn't want to go too much into the data, kind of to get all the hotel characteristics. So we just went through tables that we had available that shared the same, that had the same columns, kind of. Pretty much, yeah.
I'm a little bit confused about what you mean by the client model and what you mean by synchronized model. I saw the previous slide, but still it's not clear to me what it means. I guess my understanding that you're training one model, right? So it seems here, this table seems to imply that if a model for each client, then there is a central model. What does that mean?
Yes. There was, yeah, I guess it's like like naming here may be a little bit confusing. So we looked at every property, like all the columns besides the last, up to the last is the evaluation how well the model worked on for every property. So hierarchical model is the model that uses only the chain properties. For example, where it says hierarchical model, it combined only, like, for example, for chain 8 will be properties A1 and A2. So this is how like well it performed for every single property. For the federated learning, client actually means pretty much the same. It means like a specific property. And centralized is when we combine the properties and saw how, like, on average, that model worked for that property. If you pull all the data from the property, this is my understanding. I mean, it's like it may be.
Even for a single client, if you do federated learning, you're using data from other properties, aren't you, or no?
Yes. For the federated, I can actually tell you. The data here actually it's not exactly what I described before. It actually combined properties from the same chain only. So it was like this comparison is like hierarchical model versus federated learning. So we kind of in the hierarchical model we shared the data. In the federated learning we combined data from every also. Yeah, we actually combine the models instead of sharing the data.
So the passing is really about the last two columns, right? They are both federated learning.
Yeah. The difference between the last column, I'm not sure. It was Jorge's experiment, so I don't remember the last column. So let's say I don't know. So okay, then. Yeah, I think like we may have some more data, but I think I don't. Yeah. So this much concludes the talk. So pretty much we combine these two models, and it's still work in progress, but we're trying to find the best way to aggregate the data and to also preserve the privacy of the data. All right, so if you don't have any questions, I'll do presentation of the last kind of talk that, okay, so let me see. Yeah, I need your help.
Just to confirm, this is not in production yet, or this is already a product?
No, it's not in production. It's our experiments.
Okay.
So like we wouldn't. It's like still far, but like one day it may be in production. Yes. Thank you. Thank you very much. No, I mean, like, if it was in production, I wouldn't be probably presenting it.
You want to buy from us? You just say production.
Well, it's like, you know, it's not my kind of, you know.
Is the basic prediction routine for the choice, is it based on machine learning?
Yes, I mean, like, currently it's a machine learning algorithm, and yeah, it's machine learning algorithm. I'm not sure which one. So it's like, you know, I cannot tell you because I don't know, not because I'm kind of hiding. No, I mean, it's like it.
The reason I ask